Yes, friends, now in our previous lesson, we learned that in order to run classes on threads, we need to extend them. So, thread or runnable, which one should we extend? Sometimes, instead of creating a class and performing operations inside it, we might need to run a specific method or a specific block of code within a thread, friends. For example, let's say I have a particular piece of code. I want to quickly and efficiently run this on a separate thread. How exactly can I achieve that? And you can accomplish this using lambda functions, my friends. You define an arrow function like this. What was the logic? It was new thread, right? New thread. What does thread want from you? It wants a runnable task. In other words, an executable task. What it actually wants here is exactly the run method. You can define it directly like this. This is my run method. So what am I going to do here? For example, let me print something to the screen. Hello, I'm the first thread. My thread, for example. So what do you do next? You call start, friends. Let's write it like this here. Let's say sout program started. You can define it this way. There's no problem with that. With the same logic, what I've written here is an arrow function executing a single command. You can also provide a method here. For example, give a method here. Let it run the method in the background. You can define a method here and pass it. You can define it like this. This is related to lambda, so it's not something specific to the thread. Here, for example, you can perform multiple operations here. For example, actually, we're not really doing anything here either. It's about using the arrow function by expanding its boundaries with curly braces. So, normally, if you're going to perform a single operation, if you have just one line of code, it's logical to use it this way. But if you happen to have more than one block of code, meaning you need to write a body, you can simply open it up with curly braces like this and write it comfortably, friends. There's no problem with this either, friends. So, apart from this, how can these operations be done? How can these threads be defined? You can use this arrow function when defining a runnable method, that is, when following the functional interface logic in a structure like this, friends. Let's say runnable1 equals. Look, now you can use an arrow function like this. So, what happened? You defined a runnable method using this method. This has returned a runnable for you. What else? You can also make other definitions, friends, like this. Let's call this one runnable, runnable 2. Again, with an arrow function like this here. For example, you can define two runnables like this. So what do you need to do with these? You need to run them. Friends, what are you going to do here? You just say new thread. You can give one of the runnables to this new thread and start it. In the same way, you can also give runnable 2 here and say start. If you want, let's make this 14 instead of 4, so it loops more, for example. Then I come here and types out. Here, I just say end and it's done. The program ran. I've finished here. When you run the application, let's look at our outputs. Let's see what's here. It says the program ran. Hey, where was my first thread? Here it is. Then here we have a new thread. Look, here we first said coding. Then here, and came up. Look, why did this happen? I mean, these got mixed in here like this. So the and part got in between. Why did this happen? Guys, think of it like this now. The basic logic here is this. You ran this. Then here, you created and started a thread. Then here too, you started a thread, you created it and started it. After that, look, I defined two variables here and started a thread. Then I did this. Everything up to this point, so the new threads here are deferred to separate threads. After that, these are the runnable parts being defined. These are time-consuming things. Guys, while these are being defined, since you sent them to another thread, they're running. Look, this one has run, then this one has run. So, in the part up until it later enters the for loop, these are actually defined and sent off to the other threads. After that, this code has run. Then look, the second leading code. Look, this one has run. Then it says the third running pod has come. Where is that? Right here. This one has run. The counter is running. How far this one? 1, 2, 3. Then another counter has run. 0, 2, 4, 6. That's those friends. That's why he threw 2 by 2 here. None. This is increasing by 1, and this also increases it 2. So it goes like this. 0, 2, 4, 6, 8. And then this counter is also at 4. That meter there. That meter. Pardon, he is finishing his process. As you can see, since the system runs everyone on different threads, they all work independently from each other and finish their programs. Guys, here we saw how we can use threads by using lambda expressions and how we can run them. Guys,